and to talk a little bit about how we can make Swift and JSON be a little bit more like friends. So first we gotta ask ourselves, like, why am I here talking about JSON? Can it really be that interesting? Come on, it's just like some data format. What is going on here? Well, the thing is that most of us, we have to deal with JSON pretty much every day when we're building apps, whether that's for iOS or for Android. It's become kind of the standard data format that we're using when we're calling some web APIs. And it might not be the most elegant, or it might not be the most performant format, but it's the most common one for sure, at least currently. And people are also using JSON for other things than just like some networking, part of the networking layer. They're also using it for things like local storage, config files, etc. So it's very common to have to deal with JSON when you're building apps. In fact, my friend Orda, he has a pretty nice quote that I like to bring up, which kind of shows you what I mean by this. He said that apps are really just pretty pictures of JSON. And that might sound a little bit controversial, so let me explain it. Well, if you're thinking about it, when we're building apps, we're really just like firing out some network requests, calling some backend, and then we're downloading some data and rendering it. Whether that's like a Photos app or a Messenger or something, it's really just a rendering of data. So again, dealing with JSON becomes extremely critical to the way we build apps. In fact, at Spotify, we've taken this really a step forward, and we built a framework that we call the Hub Framework, which is a library that enables you to define entire view hierarchies using JSON and send them from your server. We had some talk earlier today that talked about similar concepts where it's really convenient to be able to specify layouts from your backend using something like JSON. And this is now an open source project that we published on GitHub. I'm going to link to it later in the slides. So we need to deal with JSON, and if we're doing iOS these days, most of us are writing our apps in Swift, or at least maybe trying it out or starting to experiment with it. So what's the problem here? Why do I feel like I need to be here today to talk about how we can make Swift and JSON friends? It kind of implies that they are not friends already. Well, let's start to take a look at some of the main characteristics of Swift as a language. What does it really do, and what is so special about it? Well, first of all, I think Swift is pretty awesome. I really like it as a language. I like the way it works. I like the syntax. And I like kind of how it's more expressive and nice to use. But one of the core principles in design choices they made when they made Swift is that they wanted to make it very safe. It focuses a lot on predictability and safety. So we have things like optionals and a really powerful type system to make sure that the code we deal with is more predictable. An integer can't all of a sudden turn into a string, so we have more predictability. Because of this, it's also more static by nature. It does a lot more checks at the compile time instead of leaving more things up to the runtime, which again makes for more safe and predictable code. And this is because of the strongly typed system that Swift is using, where types are predictable and they are statically determined. So these are some of the characteristics of Swift, but if we take a look at JSON on the other hand, we can see that we have some pretty different characteristics. I personally think that JSON is pretty cool too. Again, it's not the most sophisticated format. There are things that are, provide some features, but I just like the debuggability and the simpleness of JSON. At the end of the day, it's just a string. It's not really code. So it doesn't have a type system or strongly typed things. It's very dynamic, it's extremely flexible, and it's also very, very loosely typed. Again, it's just a string that we pull into our app. So we can see here, if we look at the left column and the right column here, we can see that we have a pretty big conflict. We have a conflict of interest. So these things are not inherently compatible, and this becomes very obvious when we start dealing with JSON and Swift. So let me show you a very simple example. Let's say we wanted to model the users that we have in our app using a very simple structure. We just want to create a user struct that has a name and an age. And the name is a string and the age is an integer. Super simple, just primitives, nothing complicated here. Which means that this should be super easy to represent using JSON. We can just create a very simple JSON file which has a name and an age, just like our structure, and just have a one-to-one mapping. So again, this is very, very simple, but let's take a look at what code we would have to write in order to fully decode this JSON into a user instance using only the Swift standard library, we would have to write code like this. And if you take a look at this, what is it that we're really doing here? Well, first of all, we get data in. We create an initializer on user, which takes a binary data. The first thing we need to do is we need to turn that binary data into a Swift object. So we use the JSON serialization API to create this object. But since JSON is so loosely typed, it can be any object. We don't really know what it is. So we need to perform a series of guard statements to conditionally unwrap all these different optionals into more concrete types. So first we check that we have a dictionary, because we need to have a dictionary to operate on. And then we check that we have a name and an age, and that the name is a string, and that the age is an integer. So this code here is of course completely valid. There's nothing wrong with only using the standard library. In fact, in some cases, it's the best thing to do. But this code here, it has some issues with it. And the first thing is that it's quite lengthy. We are only decoding the most simple structure we could ever imagine. I mean, most of us will write apps that have way more complicated models than this user model. We will have nested models with different relationships and IDs pointing to each other. So it's not so simple, which means that we would have to write even more code than this very simple example. We also have quite a lot of duplication going on here. We have all these guard statements that pretty much do the exact same thing. What they're doing is they're checking for a certain value, for a certain key. They're performing a casting and then assigning that value. And we're doing that multiple times. And because we're doing this multiple times, we also have many different exit points from this initializer. Just this simple initializer here can actually throw in 4 different places. So if you consider that for a moment, and you also consider the success case, if you wanted to unit test this initializer and this JSON parsing function, you would have to write a minimum of 5 unit test cases. And again, this is the most simple model ever. With more complex models, this just grows and grows. It becomes quite hard to deal with. But the biggest problem that I personally have with this code here is that it's not reusable. Everything that we've written here is specifically tied to this user model. We cannot reuse it for any other models, which means that when we create new models, we'll have to rewrite this code or copy and paste, which is not ideal. So when I started learning Swift about 2 years ago, I kind of tried it out this way, but I realized quite quickly I had there must be a better way moment. I felt like this cannot be the best way to deal with JSON and Swift. And again, this is something we do so often. It needs to be a better way to do it. So every time I have one of these moments, and it happens quite a lot, the first thing that I always do is that I always go to GitHub. And I see, is there some open source project or someone who's posted some gist or something maybe that can inspire me to do something a little bit better? So I jumped into the GitHub wheel and I did a quick search for Swift JSON libraries. Now, it turns out that there was quite a lot of people who had the same problems I had. And there was quite a lot of people who have attempted to solve it. In fact, if you do a search currently on GitHub, you will find 723 repository results for Swift JSON. Now that is pretty crazy. That means that there are currently 723 Swift JSON libraries out there. So clearly this is a problem that a lot of people are facing. Now, so what I did was that I started looking through all these libraries. Well, actually when I did this, it was about 1.5 years ago, so there wasn't that many libraries, but I still really couldn't find one that I liked. And this is probably this part of this presentation where you think that this Swedish guy here, he's either extremely picky or he's super crazy. Well, maybe I'm a little bit of both, I don't know. But this is what happened. But allow me to explain myself. So what happened was that the libraries that I found, they could easily be put into one of 3 categories. And the first category of libraries were libraries that provided some kind of convenience API on top of the standard dictionary. So in this library here, it gave you a JSON object, like a first-class JSON object. So you didn't have to do all of this casting on the dictionary, which was very nice. However, you still have these multiple throws inside of the initializer, so you still have the problem of the multiple exit points. And we're still having to write all this guard statements over and over again for each property. which again felt to me like this cannot be ideal. There needs to be a better way than that. The next category of libraries that I found, they took things in a completely different way, and they were very inspired by languages like Haskell or other functional programming languages, and implemented these operator overloads for parsing JSON. Now, if you're a functional programmer, maybe this is like art to you, and this looks super beautiful. I don't know. But to me, this, I have no idea what this means. I have no idea what angle bracket pipe question mark means. The only thing I recognize is code and curry. And curry just makes me think of food. It just makes me hungry. So that was not for me. The last category of libraries was libraries that actually I thought was very nice. They kind of kept the sweet point between verbosity and reducing duplication. However, what they did was they required me to have all these mutable states, to require all my properties of my models to be optional, to be mutable. And I really didn't want that, because that would mean that I would have to unwrap all of these properties every time I would use them. So every time I would use the name, for example, or the age, I would have to use this guard statement again. So it kind of defeated the purpose. So when I looked through all of these things, I started thinking to myself, and you can probably guess what my next thought was. Well, my next thought was, maybe I can make a library. You know, one rainy November day in Stockholm, maybe I can, try to make a JSON library. Why not? Right? So I decided that I'm going to give this a shot. I'm going to see if I can come up with some new technique to parse JSON that would make things a lot simpler. But before I started to write any code at all, or even started to attempt this, I wanted to set some goals for what I was about to do. And the things that I wanted to achieve was, I wanted model code that was easy to write, easy to read, and also I wanted to keep my models clean. So I didn't want to have these super long initializers with so many exit points and throws and guard statements. I didn't want to have code that was super compact and not readable at all, and I wanted things to be maintainable. So I started taking a look at what the Swift standard library did. And I took a closer look at one of these guard statements that we had before, where we were conditionally unwrapping one of these values. And I noticed that there's actually quite a lot of duplication going on in the statement here, if you look closer to it. Well, first of all, we can see that we have to specify the key that we're decoding twice. So we have to, in this case, we have to say name twice. Once when we're accessing it, and once when we're throwing any potential error. Another thing that is duplicated is the type. And here we have to specify that name is supposed to be a string. But we already know that name is supposed to be a string. All that information is already available on our model. So why should we have to specify it twice? And a little bit it felt like going back to Objective-C, where we have to declare everything multiple times. Where in this case here, we have to say that our variable is a URL, and then we also have to instantiate using a URL. A lot of duplicate information. Now in Swift, we've gotten a little bit spoiled because we've gotten used to this nice clean syntax where we can just say let URL equals URL, and the compiler knows since we're using a URL, well, it's obviously a URL. It's not all of a sudden an integer. And this is because of Swift's super advanced type inference system, where the compiler can understand our code a lot more and infer what types we mean, so we don't have to continuously specify it. So I thought to myself, maybe I can leverage these type inference capabilities for JSON coding. Maybe we can let the compiler do a little bit of the heavy lifting for us. So I wrote a very simple function that I called the code. And the code would take a dictionary as input and the key that we wanted to decode and simply return a value, in this case for a string or for an error. And then what I would do is that I would create multiple versions of this decode function for multiple types. So here's the one for integer. So it looks exactly the same pretty much, except that it checks for integer instead of a string. So why was this better than what we had before? Well now, since we have these multiple versions of the same function, what we can do in our initializer is simply call that. And when we're calling it, Swift will automatically infer what types we're expecting. So in the case of name, it will automatically know that we want a string. So it's going to dispatch to the string version. And if we want to have an integer, well, it's going to dispatch to the integer version. So we've got a lot of duplication here by inlining these functions here. And this is because it's a technique that if some of you in this room, maybe you're working on Android, you're working with Java, you're familiar with the concept of overloading. And overloading is very, very powerful, and it enables you to create methods or functions with the same signature, but with different input and output. And combine that with Swift's type inference, we get something that is extremely powerful. Because now, we don't even have to specify what types we're looking for. The compiler can automatically infer it for us. So we have to do less work, and we can actually get better performance, because the compiler can inline a lot of these things and statically dispatch to it, which makes things a lot simpler. So I realized quite quickly that it was using type inference and method overloading. That's how I was going to make Swift and JSON be more like friends. So I continued to work on this decode function, and I continuously evolved it, and it grew to have a lot more features, and eventually I decided, you know what I'm going to do? Since I love open source so much, I'm just going to open source this. So I created a library that is called Unbox, and I put that on GitHub as open source. And Unbox was, when I published it, I wanted to have kind of a little bit of a tag phrase. You know how on GitHub, I'm able to set like a title on the top of the repo, and the title I chose was the easy to use Swift JSON encoder. Because I didn't want Unbox necessarily to have a lot of complexity and a lot of features and be super powerful enterprise software or something like that. I just wanted it to be easy to use as possible. So let's take a look at the final result. What happened and what did Unbox become? Well, let's go back to this user structure from before, where we just had the name and the age. Let's take a look at how we're going to decode this now using Unbox. Well, what we do is that we conform to a protocol that is called Unboxable. So it's a completely protocol-oriented architecture that enables us to put in extensions and decouple it from our model code if we wish. What we do here is we implement an initializer that takes an unboxer, and now we can just call unboxer unbox and give it the keys that we're looking for, and that's it. That's all we need to do. So gone are all these guard statements and manual throws and type checking. That's all done under the hood in the unboxer. So how does this work? This looks a little bit maybe like black magic. Like, how does this work under the hood? Well, it actually follows the exact same approach that we had before in our decode function. The unboxer class has the method unbox just overloaded multiple times for different types. And this is how I started out with it. I started out with different return types for different implementations. But then with Swift 2, when Swift 2 came out, I realized that this can actually be made even more simple by, again, leveraging protocols and protocol extensions. So now, the implementation of the unbox method simply takes or returns a unbox compatible object, and that is implemented for all the common Swift JSON types. So here you can see there's a function or method that throws and returns T. Well, what if you don't want to throw? What if you have something that is optional, and in case it's missing, you don't want to throw? Well, the only thing we need to do is implement an overload for that, and then Swift will automatically dispatch that in the right context. Which means that if we go back to our model from before, and let's say we wanted to make the age property here optional, well, all we need to do is make it an optional property and remove this try keyword, and that's it. Now we have optional decoding instead of required. And it turns out that this method of doing JSON decoding scales very well when you add more complexity to your models. Here we have a way more complex model, even though it's still not super complex, but it's way more complicated than before. Let's say we want to put all these users in some kind of contact list where we have different groups or different friends. You can just imagine the code we would have to write in order to decode this using a standard library. We'd have to nest all these guard statements and if-lets everywhere. We'd have probably over 100 lines of code to do this. Well, with Unbox, all we do is we just create our models and we just tell it how to decode it. So we create a contact list structure and we just decode the groups property using the groups key. And then we have a friend structure which is nested, and Unbox will automatically figure it out because of how the method overloading and type inference work together. to dispatch to the right function. All right, so that's pretty sweet. That way we can handle like the success case, like if the data is there. But what about any errors that might occur? Most of the code that we write when we deal with data and coding has to do with error handling, not really with the success patch, because that can be quite simple. But as you can see, there's no error handling over here. There is no throws, there's no like handling of missing data. So how does that work? Well, the good news is that since we can leverage a single point for all of this coding, we can do error handling in a single place. And we can have a very nice unified error API that returns you a normalized version of the error. So you don't need to deal with JSON serialization error or data error or different decoding errors. You can just get an instance of the same error email back and handle that in different ways if you want to. All right, so that's kind of a little bit of like where the problem was and the kind of history behind it and how this library started to evolve. What I would love to do now is give you a quick demo of how you can do JSON decoding with a library like Unbox when you have type inference and method overloading. All right, so let's pray to the demo gods that they are going to give me some good luck today. All right, so and whoa, that's interesting. Let's that's even more interesting. Let's do the classic and just restart Xcode. It's always a good start of a demo, right? All right, there we go. Is this better? Yay! All right, looking good. All right, I'm going to see. Can we go full screen or? Yes, we can. Perfect. All right, the resolution here is pretty sweet. Let's see. I'm going to try to decrease the face size a little bit. Is that readable for you guys? Yeah. That works. Okay, sweet. All right, so I'm going to just move this over here a little bit so you can see just a little bit more of what we're doing. All right, so what are we doing here? Well, first of all, I'm in Swift Playground, which if you haven't tried it, it's awesome. I love it. It's super nice for both like experimenting with code, but also like this, like trying out different libraries, because you can actually import libraries into a playground and just try them out. So you don't have to like commit a bunch of time putting in your production code. You can just pull them into a playground, play around with them, see if it's something that you want to use. Alright, so what I'm doing here is that I'm loading some data from a URL. This is a local JSON file. In this case, I'm loading the file A, which is what you see on the right. So it's just the same file as we had in the slides. So it's just a name and an age. And I thought what we would do now is just encode that into a user structure. Again, like the example we had in the slides. So what I'm going to do here is do a block here of our do catch code. I'm going to pretty much throw this data. But the first thing I need to do is that I need to create my user structure. So I'm going to go ahead and do that. I'm going to create a string user, and I'm going to give it a name, which is a string, and I'm going to give it an age, which is an integer. And then I'm going to implement onbox in the structure. So I'm going to create an extension on user. And the good thing about creating extensions for things like this is that if you ever wanted to change which library you're using, let's say something new comes out, well, you just update your extension. You don't have to go in and tweak your model code, which is pretty nice. So I'm going to make this conform to unboxable, which will make it work with unbox. And I'm going to implement the init with unboxer initializer. And what I'm going to do here is I'm just going to tell unbox. Oh, there's a weird sound on here. I'm going to maybe it's my computer, no, it's not. All right. You guys know what it is? No, now? Okay, now it's. Can you still hear me? All right. We're going to have to try like this. All right, so I'm going to tell Unbox now how to decode my properties. So I'm going to say name equals try unboxer dot unbox, and I'm going to give it the key name because that's what we have in our JSON. And for the age, oh, I'm back, yay! I'm going to call unboxer unbox age, and that's it really. That's all we need to do in order to make our model compatible with unbox. And down here in our do block here,
we're going to say that we want to have a user, and that's a type user, and we're going to try to unbox this data here that we have that we loaded from the JSON file. And then we can just print this user here to make sure that we have a valid user instance. And we can see here that when we print it, we have it. We have the user here, and it has a name, and it has an age, just like Facebook. Alright, so that was pretty quick and pretty easy, but it was a very simple example. So let's kick it up a little notch. Let's say we want to evolve this user structure, and we want to make it a little bit more complex. So let's go to B, where we have added let's all the way to the right. We have added a profession key, where you can see that this is kind of me, right, John. I'm 29, so I'm revealing my age here, but that's okay. I'm not 30 yet, so it's fine. And you can see that my profession is developer. Now, we could, of course, add just a string to our user model and have that just be string developer, but it wouldn't be very nice. It would be much nicer to have a enum to represent this. So let's do that. So I'm going to go back to the code here, and I'm going to create an enum, which is profession. And I'm going to use a string enum so that we have a easy mapping between the string in our JSON and the Swift code. And I'm going to create a profession case for developer, which will be me. And then I'm going to create a case for another job that I really wish I had, but I don't think I ever will have. Let's say astronaut. That would be really cool to be an astronaut, I think. But yeah, maybe in another life. Alright, so how do we make this thing unboxable? Well, it's easy. We just make it conform to unboxable enum, and that's it. We don't need to write any code, we just mark it as unboxable. And then we implement the property for our user, so that will be profession, and the type will also be profession. And now something interesting happens. Now here, oh yeah, sorry, we also have to implement the coding for it. So we have to say profession equals try unboxer unbox key profession. Alright, but now something interesting happens. Now we see we have an error. Oh my god, why do we have an error? Well, we're still trying to unbox the A JSON file, which you might remember it doesn't have this key. So now unbox is throwing us an error. And you can see here this nice readable error that we get. We don't get some obscure thing. It says, an error occurred while unboxing a profession. The key profession is missing. Ah, great. So it makes it easy for us to debug. So what I'm simply going to do, I'm just going to update the reference here to point to the file B instead of A. And Playground is going to execute, and we can see now we have our user back, and we now have profession developer. Pretty sweet. Alright, let's go to the next level. Now we're close to the final boss of this little game here. We're going to level C. And in level C, we're going to introduce a nested structure. I'm doing a lot of fiddling around with the screen here. And here we want to have an array of devices that I own. So here I have my 11 MacBook Pro, I still have an iPhone 6. I don't have an iPhone 7 Plus, but I want to have an additional example. So these are nested here in an array. Let's see how we go about to unbox those. I'm just going to slide this over to the right. And I'm going to create a device structure that we're going to use. So let's do that. Struct device. And that's a name, which is a string. And we have, in the JSON, we have an inch size. And that is a double, since it can have a fractional value. An integer here is not enough. And just like we did with user, we implemented an extension for device that makes it conform to unboxable. And we implement this simple initializer in it with unboxer. So the name we can just copy right over because it's the same thing. It's just, we're just unboxing the key name. And for inch size, it's the same thing. We just say, well, we need to type it correctly. Inch size equals try, unboxer, unbox, inch size. And that's it. Alright, so how now do we tell the user that we want to have an array of devices? So the first thing we do is that we add a property on the user structure to be devices, and that is the array of device. And in our initializer, we simply decode that. So in any other normal JSON parsing, you would have to iterate over this array and put a lot of maps and tries and check things out. Well, in this case, what we do is we just say try unboxer unbox devices, and that's it. Everything else is being taken care of for us, since we have this nice recursive function which can easily go in and decode all the things that are nested. So if we again update to JSON file C, we can see we again have our user, and if we look at it, we can see that we have all of our devices there as well, automatically decoded. All right, final thing, the final example I want to show you. Let's make it even more complicated. Let's add keys for each device category. So here we have a dictionary with keys that are arrays that are dictionaries. It's like Inception. It's crazy. All right. So how do we decode this? This must require a lot of work, right? Well, not really. The only thing we need to do is update from just being an array of devices to being a dictionary of string to an array of device like that. We still have on-box key devices. We update to JSON file D, and that's it. That's it. That's all we have to do. And now we still have our user instance with all the different devices that we have in our JSON file. So we can see that by using type inference and libraries such as Unbox, we can super easily iterate on our JSON structure, and we don't have to write a lot of code. We can just tell it what we want to decode, and it's going to do it automatically. All right, so that's one use case, going from JSON to a model. But you also usually want to go the other way back. Like sometimes you want to serialize your models or send them back to the server or maybe store them locally. Well, it turns out I have a library for that too. And it's called wrap. So now what I'm going to do is that I'm going to import wrap, which basically does the Unbox stuff the other way around. So now what I can do here is that when I have a user, I can turn it back into data. So I can say let user data, which will be data, equals, oh, with a big D, equals try wrap user, and that's it. Wrap will automatically, using the Swift reflection API, look at all the properties that I have in my model and create JSON from it automatically. So we can see that we have 196 bytes here, which is probably not enough to convince you that this is actually working. So what I'm going to do now is I'm going to create a second user instance based on this data that wrap created. So I'm going to say try unbox data, user data, and we can see here now that we get the user instance back. And this is a very fun way to play around with it. Go back and forth between JSON. You can implement some tests using it. You can see I'm having a lot of fun with this. I know I'm a pretty weird guy. I like JSON parsing. Okay, that's just it. All right, so let's go back to the slides. So both Unbox and Wrap has a lot of more APIs to offer than I had time to show you today. And what's cool is that since this has been open source for about 1.5 years, there's been so many extensions added by the community. Most of the things that happen right now in these projects are not made by me, they're made by a lot of other people. So I think that's really cool when it comes to open source. All right, but that's what I have for you today. So to wrap up, I'm from Gothenburg in Sweden. We have terrible humor, and we're known for our terrible humor. Whether you choose to use some of these libraries or some other libraries, or whether you choose to create your own, maybe you even want to open source it, I really encourage you to take a look at how you can leverage things like type inference and method overloading in Swift to create more intelligent APIs that doesn't require us to specify so much at the call sides, but leverages the compiler to do the heavy lifting. And that way we can write less code, which is more performant and more predictable, which is usually a very good thing. So both of these libraries, Unbox and Wrap, they're available on GitHub. You can go to github.com/JohnSodell. I also there have a link to the Spotify framework, which I talked about earlier. We can create entire views using JSON if you so wish. And if you want to look me up on Twitter, I'm @JohnSodell there. I love to talk to developers, both Android, iOS, whatever you're into. I love having conversations online about that. But that's it for me. Obrigado! So, do you guys have any questions? Ask me anything.
Cool. Any questions?